Have you ever looked up at a row of power lines stretching between two poles and noticed how loose they seem? Instead of running straight and taut from pole to pole, the cable dips downward in a smooth curve, sagging noticeably in the middle before rising back up to the next connection point. Your brain immediately wonders if something's wrong. Did the crew run out of cable and stretch it too far? Is that sag a sign the line is about to snap? Why would anyone deliberately leave a heavy steel cable hanging loose instead of pulling it tight? Across millions of miles of power lines strung around the planet, that sag isn't an accident or a shortcut. It's a carefully calculated number, engineered down to the inch, protecting a grid worth billions of dollars from tearing itself apart on the very first cold night of winter. But here's the surprising truth. Pulling a power line tight is actually one of the most dangerous mistakes an engineer could make. Today, we're uncovering why every span of cable is designed to hang loosely on purpose, what happens to a power line as the seasons change, and why the amount of sag you see overhead is one of the most precisely calculated numbers in the entire electrical grid. This is exactly the kind of hidden detail we love uncovering here on Always There, Never Noticed. In the earliest days of long-distance electrification, some engineers tried stringing lines as tightly as possible, assuming a taut cable would be more efficient and less likely to swing around in the wind. It didn't take long for this approach to fail. As temperatures dropped in winter, the metal cables contracted and cables pulled too tight in warm weather simply had nowhere left to go once they shrank further in the cold. Towers were pulled inward under the strain, connection points cracked, and in the worst cases, entire spans of cable snapped outright. Engineers quickly realized that a power line needed room to move, expanding and contracting freely with the temperature without ever putting unbearable stress on the towers holding it up. Think of a jump rope held loosely between two people rather than pulled perfectly straight. Because there's slack built into the rope, it can flex, sway, and absorb sudden movement without yanking either person off balance. A power line works on a similar principle, following a natural curved shape called a catenary, the same shape you'd see in any rope or chain hanging under its own weight between two fixed points. As heat expands the metal cable in summer, that curve simply deepens slightly, and as cold weather contracts it again, the curve pulls back up. This built-in flexibility is called sag, and it's calculated for every single span based on the cable's material, its length, and the expected range of temperatures throughout the year. So if sag is the solution, why not just leave every line extremely loose to guarantee it never snaps in the cold? The answer, as is often the case, comes down to a careful balance between two opposite dangers. A line with too little sag risks snapping under thermal contraction or the added weight of ice and snow buildup during winter storms. But a line with too much sag can droop dangerously close to the ground, nearby trees, or passing vehicles, especially on the hottest days of summer when the cable has expanded to its lowest point. Utility engineers calculate the exact sag allowance for every span, factoring in the coldest expected temperature, the hottest expected temperature, wind load, and even the added weight of ice accumulation, then string the cable to hold precisely within that narrow safe range for decades of service. Getting this number wrong isn't just inconvenient. It can mean widespread power outages, damaged towers, or dangerous contact between a live wire and the ground below. So, the next time you look up and see a power line sagging gently between two poles, you'll know it isn't neglect or a mistake. It's a number someone calculated years in advance, giving the cable exactly enough room to breathe through every season without ever breaking.